Rahim. Assalamu alaikum dear students. This is our next problem. Problem once again having been chosen from the same book Modern Physics by Kenneth S. Crane. As usual we first come to its statement. Okay. A hydrogen atom is moving at a speed of 125 meter per second. It absorbs a photon of wavelength 97 nanometer. Nano means 10 to power minus 9. Okay, nanometer. It absorbs a photon of wavelength 97 nanometer that is moving in the opposite direction. By how much does the speed of the atom change as a result of absorbing the photon? Okay, dear students, here photon and hydrogen atom are under consideration. For this purpose we will include a helping tool in which mass number, atomic mass unit of various elements are given, and that table is lengthy enough so that it covers several pages of book. But I have just taken a snapshot of a little portion of that table. Okay. Moreover, some other helping tools will also be applied as in our previous problems. Okay. So now we come towards the helping tools. Tool number 1, which has already been chosen many times. Momentum of a photon P is equal to E over C, where E is the photon energy, C is the speed of light in vacuum. This alternatively becomes equal to HF over C, where H is Planck's constant and F is the frequency. This alternatively becomes equal to H over lambda, where lambda is the wavelength. Okay, we have discussed this definition of momentum of a photon several times. Okay, next, tool number 2 is about hydrogen atom. Okay, in this table various things are included, but we are primarily concerned only with this value. Okay, atomic mass unit 1.00782532. Okay, this we will be concerned with this value of hydrogen atom. Okay, 1.007825025032. Okay, now we see what is tool number 3. Tool number 3 has also been taken several times. Okay, in this tool speed of light is given, which will be used. Planck's constant H is given in two different system of units. This will be used or utilized. Moreover, combined value of Hc is also given. Okay, moreover, value of one atomic mass unit 1U is given, which is equal to 931.5 million electron volt over C square. From here we can also find out the value of C square. If we shift this C square, which is presently in the denominator, on other side of equality, then it will become in the numerator on other side, and hence C square will become equal to 931.5 million electron volt over U. Okay, what will be done? It will be done that C square and 1U will be interchanged. Okay, so This arrangement will also be used in our problem solution. Okay, now we come towards our solution in a proper manner. Okay, let vi, where I is written as a subscript of v. Okay, let vi be the initial speed of the hydrogen atom. Okay, dear students, speed, we know that speed is a scalar quantity, velocity is a vector quantity. When we will complete our solution, we will see that speed is becoming negative. While because speed is actually a scalar quantity, it can never be negative. Okay, so when we have found initial speed vi and final speed vf, then obviously clearly we will take their difference as change in speed. Okay, and this difference will mean greater minus smaller. Okay, if however as a fashion we take delta v, that is change in velocity equal to v2 minus v1, change in speed v2 minus v1. So if we adopt this procedure and our speed becomes negative, then we will assume that quantity to be positive, or in other words we may say that we are taking modulus or absolute value of change in speed, change in velocity, change in speed. Okay, let vi be the initial speed of the hydrogen atom, then vi is equal to 125.0 meter per second. This is given in the statement. Okay, this is non-relativistic expression. Non-relativistic expression is that where speed is much less than speed of light, and it is not expressed as a companion with speed of light. Okay, so this 125.0 meter per second is a non-relativistic expression. However, we can convert it in relativistic expression by making an arrangement. What arrangement we are going to make is that we will multiply and divide it by c, speed of light. Okay, then in the next step we will use value of c, that is 2.998 into 10 to power plus 8 meter per second in the denominator, while in the numerator we will not change or replace or affect c. Okay, in the numerator c will remain c, but in denominator c will be replaced in terms of meter per second. Okay, so by making this arrangement, vi becomes equal to 4.169 into 10 to power minus 7 c. Okay, 10 to power minus c, very less, very almost we can say negligible in comparison with the speed of light, but because it is written in terms of c, so we can assume this expression as a relativistic quantity. Now we move forward. Let pi be the initial momentum of the hydrogen atom. Okay, first we talked about initial speed. Now we are talking about initial momentum of hydrogen atom. Okay, we know that momentum is described by p, denoted by p, and initial momentum will be denoted by pi, where I is written as a subscript of p. Okay, so p is equal to mv, so pi will be equal to mvi. Vi we have calculated in previous step, in previous page of this video or of this problem. We have found value of vi. Dear students, here we are using value of m from table. which we have introduced as a tool in which atomic mass of hydrogen atom in terms of atomic mass unit is given. Okay, it was given as 1.007825032 U. Remaining portion will remain the same, that is Vi will be the same as we found in the previous step. Okay, next what we will do? Next we will do that we will eliminate U. In place of U we will put this value 931.5 million electron volt over C square. Dear students, a few minutes earlier I had described a value in the table where one atomic mass unit was given as 931.5 million electron volt over C square. Okay, and I had told that from here we can also find the value of C square, because here C square and one atomic mass unit 1 U are replaceable, interchangeable. Okay, so here we are not interchanging C and U, we are exactly taking the value of U as given in that table. Okay, so what we have done, Pi is equal to Mi, Pi is equal to MVI. We have used the value of Vi which we have calculated in previous part of this problem. Moreover, in place of M we have used that value of M which is given in the tool in which a table is introduced. Okay, in the next step we have used the value of U from the same tool or some other tool in which a table is introduced in which value of one atomic mass unit 1 U is given in terms of million electron volt over C square. Okay, clear? I hope it is clear. Okay, now what will be the next step? In the next step 1 C will be cancelled with C. Okay, in the denominator there is C square, while in the numerator there is single C. Okay, so 1 C will be cancelled out, and in the next step what we have done, dear students, actually in the next step first we have converted million electron volt into electron volt. In place of M we have used 10 raised to the power 6. Okay, and then we have simplified. Okay, actually about 2 steps have been merged in a single step. Okay, so it is not unusual. In books or in on internet at various places several steps are merged in a single step. Okay, so everything is clear. What we have done, we have just changed million into 10 to power 6, and then we have simplified the above expression, and then initial momentum Pi becomes equal to 3913.81 into 10 raised to the power 6 into 10 raised to the power minus 7 electron volt over C, and this alternatively becomes equal to 391.381 electron volt over C. Okay, so this is done. Okay, now we come towards momentum of photon. Previously we were dealing with momentum of hydrogen atom. Now we are dealing with the momentum of photon, and we have introduced a tool in which momentum of photon is properly defined, in which with circular arrowheads it is also described that this quantity is called this and this is called this. Okay, anyhow, momentum P is equal to E over C, alternatively becomes equal to H F over C, and alternatively becomes equal to H over lambda. Then what we have done, we have simply put the value of Planck's constant H and value of lambda which is given in the problem, 97 nanometer. In place of nano we have used 10 to power minus 9 meter. Okay, in the next step what we will do, we will simplify it. Just no, yes, along in addition to simplification we have again applied the same arrangement, that we have multiplied and divided it with C. Okay, in this way there will be no difference. If we multiply and divide something with the same thing, then result becomes unity. Okay, but however here the only difference is that in the numerator we are using value of C in terms of meter per second, while in the denominator we are not disturbing C. Okay, C is exactly same as it is. Okay, so after simplification it will become 0.128 into 10 to power 2 electron volt over C. So dear students, when it is being multiplied with 10 raised to the power 2, that is it is being multiplied with 100, then the effect of this multiplication with 100 will be that 0.128 will be transformed or converted into 12.8. Okay, that is to say decimal will be shifted 2 steps ahead, and then 10 to power 2 will be eliminated. So momentum of photon P will become equal to 12.8 electron volt per C, speed of light. Okay, now we come towards PF, that is final momentum of the hydrogen atom. Okay, let PF, where F is written as a subscript of P, be the final momentum of hydrogen atom. Then initial momentum is equal to okay, initial momentum of hydrogen atom is equal to momentum of photon plus final momentum of hydrogen atom. Okay, initial momentum of hydrogen atom becomes equal to momentum of photon plus final momentum of hydrogen atom. This implies that 391.381 electron volt over C is equal to 12.8 electron volt over C plus PF. Okay, because dear students, in this expression two values are known and the third value is unknown, which we are now going to determine. Okay, so out of these three values we have put two values, and then we are seeking the equality of third one, which has been still left unassigned value. Okay, so after simplification, final momentum of hydrogen atom will become 378.581 electron volt over C. Okay, because when PF will be kept on one side, then Pi minus P will be the arrangement. Okay, and when it is done, it will become so. Okay, 391 will be reduced to 378.581 electron volt over C. Okay, now let Vf be the final speed of the hydrogen atom. let Vf, where F is written as a subscript of V, be the final speed of the hydrogen atom. Then according to the classical expression, non-relativistic expression, momentum is equal to mass into velocity. Okay, P is equal to mv. So this implies that here, because we are going to find final speed, so Pf, that is final momentum, will become equal to m into Vf. Next, in the next step, we have put the values of Pf and m. The value of m has been selected from tool, in which a table is introduced, in which mass of hydrogen atom in terms of atomic mass unit is described, is given. Okay, so from here, dear students, what we have done here, once again, first we have replaced m with that value which appears in the table, and in the next step we have eliminated u, that is atomic mass unit, and in place of u we have used its alternate value in terms of million electron volt over c square. Okay, in the beginning of this video or problem, I had emphasized enough on these arrangements. Okay, so 931.5 million electron volt over c square multiplied with Vf, final speed, final velocity, which we have to determine. Okay, so this implies that this becomes equal to this into this. Okay, simply we have multiplied 1.000 with 931. So because this quantity is very less greater than 1, so 931 has been increased from 931 to 938.789. okay, so after simplification we will get the value of Vf equal to 378.581 electron volt over C into C square over electron volt. Here, dear students, C square will be 1C will be cancelled with the C, and we will be left with only 1C. Okay, so final speed Vf will become equal to 4.033 into 10 to power minus 7 C, speed of light. In the next step, we have replaced C with its value in terms of meter per second, and after this arrangement, final speed Vf has become equal to 120.91 meter per second. While, dear students, initial speed which is given in the problem is 125, about 125. Okay, yes. So delta V, that is change in speed, is equal to Vf minus Vi is equal to 120.91 meter per second minus 125.0 meter per second, and this alternatively becomes equal to minus 4.09 meter per second. This is change in speed. Because speed is a scalar quantity, it can never be negative. So actually we should subtract smaller quantity from larger quantity. Okay, here we should use delta V equal to 125.0 meter per second minus 120.91 meter per second. Then result will become equal to plus 4.09 meter per second. However, in order to cover this irregularity, we have taken absolute value, which is also called modulus. So modulus of delta V, that is change in speed, is equal to modulus value of Vf minus Vi is equal to plus 4.09 meter per second. And this is the end of our problem, end of our video. Till next video, Allah Hafiz.